Balancing the redox reaction below in the acidic medium using half reaction method. There are 5 rules which are used to balance the redox reactions in the acidic medium. The redox reactions involves both oxidation and reduction. Some of the chemical species are oxidized while others are reduced. Let's start with reduction half reaction. Reduction half reaction. The one which undergo the chemical species which undergo reduction is this one. Dichromate ion undergoes reduction. It is an oxidizing agent, so during the chemical reaction it undergoes reduction. This is in acidic medium is converted to chromate 3 ions. Chromium 3 ions. Chromium 3 ions. Now, first rule is to balance first the materials. Materials are atoms of all elements apart from oxygen and hydrogen. All atoms of elements apart from hydrogen and oxygen are referred to as materials. Chromium, on the reactant side, there are 2, but on the product side, there is 1. So this is 2, trial and error method. Then after that, the next one is to balance the number of oxygen atoms. The number of oxygen atoms is balanced by adding proper number of water molecules to the side where there are no oxygen atoms or there are fewer oxygen atoms. On the reactant side, there are 7 oxygen atoms, but on the product side, there are no oxygen atoms. So we have to add a proper number of water molecules to the product side where there are no oxygen atoms. But how many water molecules are added? 7 water molecules. Why? Because each water molecule contains only 1 oxygen atom. By adding 7 water molecules, we have added 7 oxygen atoms. Now 7. Then hydrogen. Then we have to balance hydrogen atoms. The hydrogen atoms are balanced by adding a proper number of hydrogen protons to the side where there are no hydrogen atoms or there are fewer hydrogen atoms. In this particular half reaction, there are no hydrogen atoms on the reactant side, but there are 227, 14 hydrogen atoms. So we have to add 14 hydrogen protons to the side where there are no hydrogen atoms. 14 hydrogen protons. Then after that, after balancing the number of hydrogen atoms, we have to balance the number of charges. Number of charges, this is +1 and 14, +14. And this is -2. +14 plus -2 plus -2. This is equal to +12. But on the reactor, on the product side, charge is 2 times +3. This is equal to +6. And this is neutral. Charge is 0. So the total charge on the product side is +6, while the total charge on the reactant side is +12. So in order to balance the number of charges, we have to add the proper number of electrons to the side where there is high charge. The reactant side has high charge, +6, but we have to. What is the number of electrons to be added? The number of electrons to be added is 6 electrons. By adding 6 electrons is equivalent to add -6. So +12 and -6 is equal to +6. The number of charges are balanced. Then after that, we have to balance the oxidation half reaction. Then oxidation half reaction. Oxidation half reaction. Oxidation half reaction. On oxidation half reaction, This one undergoes oxidation. So materials are balanced first. Then this is a gas. Then this is auxiliary ion. The auxiliary ion is converted to carbon dioxide in acidic medium. So we have to balance first the material. Material, carbon 2, but on the product side there is only one carbon atom. So we have to balance the material by trial and error method. 2, 2. Then after that, balance the number of oxygen atoms. The number of oxygen atoms is balanced by adding proper number of water molecule to the side where there are no or fewer hydrogen atoms. On the reactant side, there are 4 oxygen atoms, but on the product side, there are 2 times 2, 4 oxygen atoms. So the number of oxygen atoms have been balanced. Then we have to balance the number of hydrogen atoms, but on the reactant side, there are no hydrogen atoms, and on the product side, there are no hydrogen atoms. So we cannot balance the chemical species which is not there. But also, the number of charges. Number of charges on the reactant side, there is positive and negative 2, and the charge on the product side is 0. This is neutral. 0. 0 and negative 2. 0 is higher than negative 2. So we have to add the proper number of electrons to this side that there is high charge, 2 electrons. By adding 2 electrons is equivalent to add negative 2. Now the charge has been balanced. Then after that, we have to we have to obtain the overall reaction. The overall reaction. Add together the half reactions so as to get the overall reaction. But in order for the 2 half reactions to be added together, the number of electrons in reduction half reaction should be equal to the total number of electrons in oxidation half reaction. So 2, 3, 2, 6. So we have to multiply this oxidation half reaction by 3 in order to obtain, in order to make the number of electrons in oxidation half reaction to be equal to the number of electrons in reduction half reaction. This is multiplied by 1. Then after that, this is the overall reaction. This is chromium 2 aqueous plus 14 hydrogen protons plus 6 electrons. Two chromium 3 ions plus 7 water molecules. And this is the ray aqueous. 2 the ray times 2, 6 carbon dioxide. Plus 3 times 2, 6 electrons. Then after that, the number of electrons are equal. The number of electrons is 6, and here is 6. Then to obtain the overall reaction, you have to add together the 2 half reactions. Now, overall reaction. By adding together the number of electrons cancel, the number of electrons cancel. Then the overall reaction is chromium ion aqueous plus the chemical species which are on the reactant side are added together. Now these are added with this, and on the product side are added together. These are added with these chemical species. Now this 3 aqueous plus 14 hydrogen protons to form 3 chromium 3 ions plus 6 carbon dioxide gas plus 7 water molecules. This is how to balance this redox reaction.